Oh, no. Okay.
I'll come back in a second, okay. So, are we happy that sine is made up of opposite divided by hypotenuse? Is that fair enough? Okay. So, the ratio, the opposite divided by the hypotenuse has to be a half for 30. It's been proven. So, say that's 5. That mathematically has to be 10. Is that fair enough? Okay. So, as a triangle gets bigger, so say we had 10 there, are we happy that that's going to be 20 there? Okay. So, even without, if I knew that was 30 there, I can now work out that has to be 10 because those two values divided together have to be a half. And that's what your calculator has, all the ratio numbers. Now, by definition as well, if you look at the sine graph, are we happy to accept that the sine of 30 is 0.5? Yeah? There are multiple angles by definition that have the same ratio. Can you give me another one that you think will be the same? The sine of an angle that gives me 0.5. Can you see it on the graph at all?
150.
150 is great. Why is it 150, do you think, Toby? Where'd you get 150 from?
Because it's a symmetrical line. So
Brilliant. That's perfect, yeah, because it's symmetrical. Can you see that it's symmetrical? So can we see that the gap here, really roughly drawn, is 30? Can you see that space is 30? So this one over here, if you take off the 30 gap, you should have 150. So can you type into your calculator the sine of 150, and does it give you the same ratio number of 0.5? It does. Okay, are we okay with that? So mathematically, we can find multiple answers. So you need to know that sine of x is going to be the same as the sine of 180 minus x. You okay with that? So if you've got 45, sine of 45, for example, that would be the same as the sine of 135. Okay, you happy with that? Sure? So can you make a little note somewhere that the sine of x is the same as the sine of 180 minus x? So if I said to you sine 30, what else is it same as the sine of 150? If I say to you sine 10, you happy with it being the same as sine of 170? And when we do trig equations, we're going to do a lot to do with the graphs and solving things, because you're going to have multiple angles because they go round and round and round. Okay? Are you okay so far? Let's just try one of these problems that Toby was talking about. Okay, can we try next set then? Could you draw it and see if you can work it out? What rule should we use? Sine and cosine rule?
Sine.
Sine, how rule is sine? Because you've got the opposites, is that fair enough? And it's like you haven't got enough to use the cosine rule. Okay, what does your calculator give you? 67? So 67? Okay, so say that's 67, that's fine. That's one possible answer. So we've got 67 degrees. By our diagram, is it fair to say that it looks like an acute angle and it's 67? Okay, so the way that we've drawn our triangle. But mathematically, there's no reason why the triangle, if we were to draw it, could look something like this. Is that fair enough? Okay, so actually, we've got 67 in the way the shape of the triangle looks, but we could have also drawn it like this. Is that fair enough? So if I put 3 back in there, get rid of that. So your calculator will always give you a starting point, and it always gives you the acute angle. So we could have that. Is that fair enough?
Yeah.
Okay. But it will only give you one answer because it can't give you multiple answers. So 67 is correct. What is the other angle that it could have given you that could lie there? Think about what I just said as well.
112.
112. Okay,
Yeah.
so because this angle is the same as that one with sine, when we refer back to sine, so this could also be 180 minus the 67. So it's going to be the 113 or whatever it is. Does that make sense? Yeah?
Yeah.
Okay. Yes or no? Because mathematically, say sine of 30 is the same as sine of 150. The sine of